We are starting with Maths Chapter 3, Coordinate Geometry. This is a very small, very simple and very easy chapter. The exercises are also not much. There are only two exercises, also very small. Concept is very easy. So many of the schools, I think 90% of the schools will have this chapter in their first term. That's why I'm teaching this chapter. So we are going to learn something new in this chapter, and it is related with graphs. So we are going to use it further in two of the chapters in ninth class. That is, one is linear equation in two variables, and the second one is statistics, basically graphical representations. So let's start this chapter, coordinate geometry, and finish it, right? In one video this will be over, so not a big deal. uh, let's start. Okay, first some introduction. Okay, it is must to have some introduction before we start this topic, because many of you should know, most of you, all of you should know the idea behind or the details behind this particular topic. So, what is the idea behind coordinate geometry? Let's read. In ancient days, Indians and Greeks used to study geometry, which was free from the use of algebra. So there was no algebra in the geometry in the ancient days. This approach of studying geometry was continued for 1300 years until the French mathematician René Descartes. René Descartes. I don't know how to pronounce this in French pronunciation, but the name is René Descartes. Okay, who gave a new idea of combining two branches, that is algebra and geometry. So René Descartes, this guy, he combined algebra and geometry. The wedding of branches is known as analytical or coordinate geometry. Why coordinate geometry? Because both the branches are working together here, right? See, no questions will be asked on this history, but because it's interesting, so you should know. Descartes introduced Cartesian system of coordinates. So he put forward this new system which is known as Cartesian system of coordinates for describing the position of a point in a plane. So the use of this Cartesian system of coordinates in coordinate geometry is to describe the position of a point in a plane, right? In this chapter, we shall define the coordinates of a point in a plane with reference to two mutually perpendicular lines. So we will have two mutually perpendicular lines which are known as, okay, I'll tell you about that later. Uh, we shall also learn regarding the plotting of points in the Cartesian plane, right? So the chapter deals with majorly two things. Defining the coordinates of a point in a plane, that is number one, with reference to two mutually perpendicular lines, of course. So defining the coordinates of a point in a plane and plotting the points in the Cartesian plane, right? So these two things we have to learn in this chapter. So I'm sure that you have idea about what we are going to do over here. Let's start. Okay, first understand the first topic, that which is ordered pair. What is ordered pair? A pair of numbers a and b which are listed in a specific order. A at the first place, A at the first place and B at the second place is known as ordered pair. Okay, so A and B, these are two numbers. They are listed in a specific order, which is abbreviated as bracket, in the bracket A comma B. So if you write A comma B, it is an ordered pair. A is in the first place, B is in the second place. Okay, so for example, 2 comma 5 is an ordered pair, 5 comma 2 is also an ordered pair, right? More examples we can take. Minus 3 comma 7 can be an ordered pair, 0 comma minus 4 is an ordered pair, right? 4 comma minus 3 is an ordered pair. These are all ordered pair. But please remember that a comma b is never equal to b comma a unless a is equal to b. Right? Suppose I take an ordered pair 3 comma 3. 3 comma 3 is equal to 3 comma 3. Now what I've done is I've switched the places of both the threes and I've written here. But you don't know. You will never know that I switched the places of 3 or not. Right? Because they both are same. So if both the elements are same, if if A is equal to B, then we can say that A comma B is equal to B comma A. If A is not equal to B, then we cannot say that. Right? So ordered pair, you must be very cautious regarding the positions of the elements, position of the numbers. They cannot be changed. Like if you say I have a number 2 comma 3, I have an ordered pair 2 comma 3, and if I say I have an another ordered pair 3 comma 2, these two ordered pairs are not equal. Why are they not equal? Because the positions are changing. Both the numbers in the ordered pair are not equal and the positions are changing. That means the ordered pair is different. Okay, so position should not be same. Okay, this is okay, but this is not okay. Right? So now you know what is an ordered pair. Okay, let's go to the coordinate system. What is a coordinate system? Do you see a graph paper? Right? A graph paper. Now, the graph paper in front of you has all the numbers on two mutually perpendicular lines. Okay, so let us first understand what you see over here. So there are two mutually perpendicular lines. That means this angle is 90 degree. Let me just draw it neatly. This angle is 90 degree. You see the horizontal line which looks just like the number line. You've studied number line, right? In 8th class. Yeah, so the horizontal line looks just like the number line. In the middle of the horizontal line, there is 0. So this point where the two number lines intersect each other is known as origin. What is this point known as? This point is known as origin. Origin. Okay, origin is the point where two perpendicular lines intersect each other. You know your number line, right? Suppose I draw a number line and show you. Suppose this is your number line. Now there is 0 over here. Then there is 1, 2, 3, 4, 5. Then there is -1, -2, -3, -4 and -5 and so on. So this 0 is exactly in middle, right? To the right of 0 there are all positive numbers. To the left of 0 there are all negative numbers. So what is this 0? 0 in our coordinate geometry is known as origin. Origin. So origin is nothing but 0. Now just imagine there is a vertical number line. A number line can be horizontal and vertical also. I can draw number line however I want. So if this is a vertical number line, all the numbers above 0 will be positive. 1, 2, 3, 4, 5. All the numbers below 0 will be negative. -1, -2, -3, -4, -5. Right? So this is a vertical number line. What is in the middle? In the middle there is 0, which is known as origin. Now just do one thing. What we are going to do is we are going to combine these two number lines. So I'm going to draw a horizontal number line and then I'm going to draw a vertical number line. Right? And both of them, they will meet at one point, which is known as the 0. And this 0 is nothing but the origin. Right? So that is the basis of your coordinate geometry. Right? Coordinate geometry has basically two number lines. one horizontal, one vertical, both perpendicular to each other, and the point at which they intersect, both the number lines intersect, is known as origin. Okay, remember the name origin. Okay, now what is this horizontal number line known as? It is known as x axis. It is known as x axis. What is the vertical number line known as? It is known as y axis, right? X axis, y axis. So x axis is always horizontal. Remember this. I'm going to give you some cues over here. Let me write over here. X axis, x axis is always horizontal, right? Y axis is always vertical. X axis is always horizontal and y axis is always vertical. Remember this, please remember this. Okay, now both these axes, both these number lines, one horizontal, one vertical, they are together collectively known as axis. Okay, axis also spelled, also pronounced as axis only. Okay, so axis, axis, axis is singular. For a single number line, I will call it axis, axis. Okay, single number line, singular. And for plural, for both the number lines together, I will call it as axes, axis. Okay, so that is plural. Okay, so how many axes does the Cartesian coordinate system have? Two. Which axes are these? X-axis and y-axis, right? And where do they intersect? Origin. What is origin? 0, right? So that is your coordinate system. This is what is the coordinate system. Okay, let's go ahead. Okay, now what we have done over here is we have found coordinates of a point. Okay, so we have located a point. Now as you can see here, I can just fill this up quickly. -6 and -7 over here, right? So as you can see over here, this coordinate, this Cartesian plane has been divided into four quarters. Four quarters. These four quarter means one fourth part. You see the one fourth part? I will show you where the one fourth part is. This is one part. This is the other part. Wait, other color I will do. Right? Then the third part. Wait. Let me choose nice colors. Okay. This is the third part. And one more color, please. Thank you. This is the fourth part. So these are the four parts, four layouts. In all these four parts, there are some points. And what we can do with the help of coordinate geometry is locate these points. You know, the map, the globe, the map of the world, map of a country, right? You know, there are points which are known as latitudes and longitudes. You know them? Latitudes and longitudes. They are based on the same system. So if you know the latitudes and longitudes of a place, that means you can identify that place on the map. Or if you know the place on the map, you can identify its latitudes and longitudes. So what we are doing is basically this is our map. This Cartesian plane is our map. And this plane, for our own reference and for our own convenience, has been divided into four quarters or four one-fourth parts. Like if you see, this is one-fourth part, this one is also one-fourth part, this is also one-fourth, and this is also one-fourth. All these parts have certain points in them. Like one point they have shown here, they have plotted one point over here, 3, 4. Now as you see 3 comma 4, what is 3 comma 4? 3 comma 4 is an ordered pair, right? So this has a special meaning. So let me show you the first, let me explain you the meaning and then we'll come to the graph. Suppose if I write 3 comma 4, okay, so I will call it coordinates, this is C, coordinates of a point. Now always remember, coordinates of a point are always in the form of x comma y. So the first number in the ordered pair, the first coordinate of the ordered pair is always x coordinate. Okay, the second coordinate is always the y coordinate. Now you will ask me, sir, what is x coordinate? X coordinate in simple terms I can explain you as x coordinate is the perpendicular distance of a point from y-axis. How far a point is from y-axis is the x-coordinate. Now you will not understand what I am talking about until and unless you see this on the graph paper. But you will see it on the graph paper. Okay? First understand the meaning, then we'll go to the graph paper. Okay? Don't worry about the graph paper. I'm going to bring one more graph paper here and show you. Don't worry about that. What is y coordinate? Y coordinate is the perpendicular distance of a point from x-axis. Okay, so x coordinate is the perpendicular distance of a point from y-axis and y coordinate is the perpendicular distance of a point from x-axis. So these are the meanings of coordinate. Now let us see where do this coordinate actually lie, or how we can find the distance of a point from x and y axis. Suppose the coordinates here are 3 and 4. Can you tell me what is x coordinate? Tell me fast. X coordinate is 3. Very good. What is y coordinate of this point? Over here? What is the y coordinate? 4. How do you know that x is 3, y is 4? Due to the ordered pair. In ordered pair, the first coordinate is always x coordinate, the second coordinate is always y coordinate. So x is 3 and y is 4. That is very easy. Now I told you what is x coordinate. X coordinate is the perpendicular distance from y axis. Now this is your y axis, right? If I take a perpendicular distance from this y axis, right? How much is this distance? How much is this distance over here? Can you tell me? This distance, see how many blocks are here? 1, 2 and 3. So this distance is nothing but 3 units. And that is why the x coordinate is 3. So x is nothing but the perpendicular distance from y-axis. And you can also say it here. See, you can, if you see on x-axis, where does this point lie with respect to a number on x-axis? It lies right above the number 3. So its x coordinate is number 3. Right? Now what is y coordinate? Y coordinate is the perpendicular distance from x-axis. So see, this is x-axis here. What is the perpendicular distance from x-axis? How much is this distance? How many blocks do you see? I see 1 block, 2 block, 3 block and 4 block. So what should be this distance? This distance should be 4. Yes, it is 4. And if you take this point and project it or find a horizontal line towards y-axis, where does this point meet the y-axis? At point 4. So any point, wherever it meets the x-axis and y-axis, it will show its x and y coordinates respectively. Right? So this point meets x-axis at point 3, so its x coordinate is 3. This point also meets y-axis at point 4, so its y coordinate is 4. Let me take another example and show you in this graph itself. Okay, I'll take one example. Okay, I'm drawing lines, okay, for your reference. Suppose I'm talking about this point, and this point, let me name it as Q, and its coordinates are x comma y. Can you tell me the values of x and y? Can you tell me what are the x coordinate and y coordinate? The x coordinate is the point where the line joining this point and x axis meet at x axis. So this point, if I draw a line from this point to x axis, it meets at -4. So what is the value of x? -4. What is the y coordinate? If I draw a line from this point to y axis, it perpendicular line, of course, it meets at 2. So what is the y coordinate? 2. So what is the ordered pair? What is the coordinates of q? We talked like this. What are the coordinates of q? The coordinates of q are -4 comma 2. Again an ordered pair. What does it show? It shows the location of q. So now you know what does the coordinates show. Coordinates show the location of a point. Where? On the Cartesian plane. What is Cartesian plane? Graph paper. Okay, how many parts is the Cartesian plane divided into? Answer these questions. Okay, whenever I am asking, it is a YouTube video, I know it. You cannot answer and I cannot hear you. But when you answer it in your mind, the information is already programmed into your mind. So whenever you solve these kind of questions, whenever these problems come in front of you, you can easily identify the answers. So let me tell you, again ask you one question, okay, and give you answers also. So you also answer before I give you the answer, okay? How, uh, no, not how. Yes, how. Yes, I'm sorry about that. How do you locate a point on a Cartesian plane? How do you locate a point on a Cartesian plane? You can pause, think, answer yourself. Listen to my answer. You locate a point on Cartesian plane with respect to coordinates. What are coordinates? What are coordinates? The answer is coordinates are numbers. Coordinates are numbers which specify the distance of a point from x-axis and y-axis. How many types of coordinates are there? There are two types of coordinates, x coordinate and y coordinate. What is x coordinate? X coordinate is the distance of a point from y-axis, or x coordinate is the point uh, which joins the x-axis when joined with a perpendicular line, right? So distance from y-axis, or the point which joins with the given point with a perpendicular line, its value is known as x coordinate. What is y coordinate? Y coordinate is the distance from the x-axis, or if you join the point with y-axis with a perpendicular line, the location of that point on y-axis is known as y coordinate. We just saw here, right? Okay, so how many parts is the Cartesian plane divided into? The Cartesian plane is divided into four parts, right? Four parts. We saw that four parts. In all those four parts, there are some points. We can locate those points with the help of their coordinates, right? Okay, what are those lines which divide the Cartesian plane into four parts? Answer yourself. What are those lines which divide the Cartesian plane into four parts? Those lines are axes. How many types of axes are there? X-axis and y-axis. right? X-axis is horizontal and y-axis is vertical. What is the point at which x-axis and y-axis intersect each other? The point is known as origin. And now the most important question I'm going to ask you. What are the coordinates of origin? How far is origin from x-axis? 0 units far. How far is origin from y-axis? 0 units far. So the coordinates of origin are 0, 0. Right? Let me just give you this idea of whatever I've talked here. Right? Coordinates we just understood over here. Right? 3, 4 are coordinates of a point. Coordinates of a point are written in the form of ordered pair, which is x comma y. X is always written first, y is always written the second. X coordinate is the perpendicular distance of a point from y axis, and y coordinate is the perpendicular distance of a point from x axis, right? If you look into the graph and match these definitions, you will exactly get the idea. Okay, now what are the coordinates of origin? Coordinates of origin are 0, 0. Remember this, coordinates of origin are 0, 0. Okay, so that's your coordinate system. That's how to locate the point. Okay, mm, let's do some more important facts based on your coordinate geometry. The first is abscissa. Abscissa is the perpendicular distance of a point from y-axis. An ordinate is the perpendicular distance of a point from x-axis. Okay, so what is abscissa? See, I told you x coordinate, right? Suppose if I take an ordered pair 3, 4. What is x coordinate? X coordinate is 3. And x coordinate is also known as abscissa. Therefore, abscissa is also 3. So that means x coordinate is also known as abscissa. So that's another name for x coordinate, abscissa. Okay, you know what is x coordinate, right? Suppose again I'm going over here and plotting a point. Let me plot a point. Let me plot a point over here. Suppose this is my point. Okay, let me name it R. Can you tell me what is the x coordinate of R? You just have to draw a perpendicular line from this point to x axis. Where does this line meet x axis? Where does this line meet? -2. So what is the x coordinate? -2. What is the abscissa? What is the abscissa? -2. Right? Let me clear this. So again, let me tell you. What is the x coordinate of point R? -2. What is the abscissa of point R? -2. Okay. What is the y coordinate of point R? So you have to draw a perpendicular line to y axis. Where does it meet y axis? -3. So what is the y coordinate? -3. What is the ordinate? -3. So that's where I'm coming to the point. Okay, if the point is 3, 4, x coordinate is 3, therefore abscissa is also 3. And what is the y coordinate? Y coordinate is 4, and therefore ordinate, y coordinates another name, ordinate, is also 4. Right? So two new names for x coordinate and y coordinate which you must keep in mind. Abscissa is positive to the right of y and negative to the left of y. Okay, yes, we know that. As you go to the right side of origin, the abscissa becomes positive. Just like number line, abscissa means x coordinate. And as you go towards the left side of origin, the abscissa becomes negative. That is, x coordinate becomes negative. As you go above x axis or above origin, the ordinate becomes positive. And as you go below origin or below x axis, the ordinate becomes negative. Right? So these are the sign conventions we are coming on. Abscissa of any point on y axis is 0. Okay, let me just clear this thing up and explain you again. There's too much of mess over here. Let me clear this. If I do stroke eraser, this is better. Okay, let me let me clear this also. Not required now. Okay. Suppose if I choose a point on x-axis. Suppose let's say my point is over here. This is my point on x-axis. Can you tell me what are its coordinates? What is the x coordinate of this point? The x coordinate of this point is 6 because it is lying on number 6 on x-axis. What is the y coordinate of this point? See, y coordinate is the perpendicular distance of any point from x-axis. How far is this point from x-axis? This point is not anything far from x-axis. It is on the x-axis. So its y coordinate will be 0. So any point which is lying on x-axis has its y coordinate as 0. Any point which is lying on x-axis has its y coordinate as 0. So ordinate will be 0. Okay, so that is what that point explains over here. Abscissa, oh sorry, sixth point, ordinate of a point of any point on x-axis is 0. Now the fifth point, now I'm covering the fifth point. Let us take an example of a point on y-axis. Let us take an example of this point. Okay, what is this point? This point is, what are the coordinates of this point? What is the x coordinate of this point? X coordinate is the distance of the point from y-axis. How far is this point from y-axis? 0 units far. It is on the y-axis. And how far is it from x-axis? 3 units away. So what are the coordinates of this point? 0, 3. What are the coordinates of this point? 0, 3. Right? So if the coordinates of this point are 0, 3, then can you tell me can you tell me anything about its abscissa? Its abscissa is 0. So abscissa of any point on y-axis is always 0. Ordinate of any point on x-axis is always 0. Or in the other words, x coordinate of any point on y-axis is always 0 and y coordinate of any point on x-axis is always 0. Right? So these are point number 5 and 6. Coordinates of the origin are 0, 0. We've just learned that. The ordinates of all points on a horizontal line are equal. Oh, any horizontal line you take. Suppose if I draw a horizontal line, let me draw a line, okay, from this point, and I will extend it over to this one. Okay, so suppose now I have a line. Take a point on this line. Suppose this point. What are the coordinates of this point? Okay, where does this point meets x-axis? Over here. So x coordinate is -4. What is the y coordinate? Where does this point meet the y-axis? -3. So the coordinates of this point are -4 and -3. Suppose I take this point. What is the x coordinate of this point? 2. Right? What is the y coordinate of this point? -3. So any horizontal line, if you take any horizontal line, they will have all the ordinates same. Ordinate means y coordinates. -3, -3. Any horizontal line, wherever you draw horizontal line, whatever ordinate you will get, they will be always same. So that is the point number 8. Point number 9 is abscissa of all the points on a vertical line are equal. Let us draw a vertical line. Let us draw a vertical line and see. Right, so I'll draw a line over here. Let me draw it over here. Okay, so there's my line. Okay, let's take this point. Can you tell me the coordinates of this point? First, x coordinate. So where does this point meets x-axis? 6, right? So x coordinate is 6. What is the y coordinate? Where does this point meets the y-axis? 5. Then this point. What is the x coordinate of this point? 6. What is the y coordinate? 3. Then this point, right? What is the x coordinate of this point? 6. What is the y coordinate? -3. This point. What is the x coordinate? 6. What is the y coordinate? -5. Right? So 1, 2, 3, and 4. We have got 4 points with x coordinate, all of their x coordinates same, abscissa same, and y coordinate different. Why? Because they all lie in the same vertical line. So that is point number 9. The abscissa of all the points on a vertical line are equal. So all the points are covered over here. I have explained you the Cartesian plane in detail in now 36 minutes going on to this class, and I have explained the Cartesian plane to you in detail. I could not explain to you in classroom this way because I have these tools. I'm using these softwares now, so I can easily show you what is going on over here. So by now you should be able to plot a point. By now you should be able to define, at least loosely define, what is x coordinate, y coordinate, what are coordinates, right? What is origin, what are axis, what is x axis, y axis, what is abscissa and ordinate. Of course we have done that, right? And these important facts you've all understood. Okay, let's go to sign convention. Okay, just a moment. Okay, so there is a graph paper in front of you. uh, Tell me, what is this point? Oh, I'm sorry. Oops. भाई चला जा, क्या कर रहा है? एक मिनट, just a moment. Okay, so this point is 0, right, which is your origin. Then this is 1, then 2. Let me make my pen a little thinner. Okay, this is 3, this is 4, 5. This is too thin here. 6, 7, 8, 9. Okay, so this is your x axis. This is your, I'm just going to write here, y axis. Okay, this is 0, so this is 1, 2, 3, 4, 5, 6, 7. Okay, on x axis and y axis I have plotted a few points. Now do you notice that this section which I am talking about right now, this, I told you one name for this section, right? This is known as a quadrant. Right? I'm sorry, I'm just going to erase this, man. Just get, there's some issue. 1 second. Okay, so this section which I have written the numbers right now, in this section, all the x coordinates and the y coordinates, they are all positive. So we can say that x coordinates are positive and y coordinates are also positive. So our ordered pair will be in terms of plus comma plus. You understand? The ordered pair will be both positive. X will also be positive and Y will also be positive. So this basically is known as the sign convention. What is this? What is it known as? Sign convention. Just let me write it over here. So sign convention. Convection nahi convention. Sign convention. Okay. So let me draw a small table for you rather than writing like this. Uh, Insert a table, sign convention, quadrant and sign convention. 1, 2, 3, 4. Okay, that's enough. Let me draw it here. Let me bring this here and make it a little bigger. So, quadrant number and sign convention. Okay, quadrant number and sign convention. Oops. Just a moment. I'm just going to insert one more. Yeah. Okay. That should be okay. Okay. So I'm talking about first quadrant over here. So this is nothing but first quadrant. Okay. And first quadrant sign convention is plus comma plus, means both x and y, uh, x coordinate and y coordinate have positive sign in the first quadrant. Why? Because we are seeing all the x coordinate on the right side of origin. On the right side of origin, all the x coordinates are positive. Also, we are seeing all the y coordinates above origin. Above origin, all the y coordinates are positive. So first quadrant has the sign convention of plus plus. Let's look at the second quadrant. This is the second quadrant. Okay, we go anti-clockwise, not clockwise. So we basically go like this. Okay, anyways, let me. So this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9. Right? So the second quadrant has the sign convention of, what is the sign of x coordinate? Minus. And what is the sign of y coordinate over here? Plus. First, always you have to write x and then y. So x coordinate all are negative in second quadrant and y coordinate all are positive. So if I want to mention the sign convention in this table for the second quadrant, x is negative, y is positive, right? Let's come to the third quadrant. Where will be third quadrant? This is first, this is second, so this will be the third quadrant. And here I will write nothing. X-axis, y-axis, okay. X dash some people write, but it's okay. So I'm just going to mention the numbers over here. So this will be minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. By now you should know what is the sign convention of this third quadrant. X coordinate are negative, y coordinate are also negative. So the sign convention for the third quadrant is minus minus, right? So the sign convention for quadrant number 3 is minus minus. Now we are left with fourth quadrant. So fourth quadrant is over here. What is the sign of x coordinate? Plus. What is the sign of y coordinate? Minus. So sign convention is plus minus. So these are the sign conventions. So if suppose somebody would tell you without looking at the graph, okay, without looking at the graph, and then we'll look at the graph and match the answers. So without looking at the graph, tell me in which quadrant does the point 2 comma 3 lie? Yes, 2 comma 3 lies in the first quadrant, right? Why? Because I just looked at the sign convention. Sign of 2 and 3 both are positive, so it lies in the first quadrant. Where does minus 3 comma minus 4 lie? Third quadrant. Where does minus 2 comma 6 lie? Second quadrant. Where does 4 comma minus 5 lie? Fourth quadrant, and so on. So just by looking at the signs of the numbers, you can predict in which quadrant they are lying. Now let us plot these points and check. First point is 2 comma 3. I will write the points over here, so I'll be able to see 2 comma 3, then minus 3 comma 4, then minus 2 comma 6, and my 4 comma minus 5. Hey, third quadrant will be minus 3 comma minus 4 and 4 comma minus 5, right? So these are the 4 points in 4 quadrants according to the sign convention. Now let us plot the points and check whether they actually lie in this quadrant or not. First is 2 comma 3. So where is 2? Over here. Where is 3? Over here, right? Plus 2 is here, plus 3 is here. Now if I make a perpendicular line from plus 2, and if I draw a horizontal perpendicular line from plus 3, they will meet at this point. So this is nothing but 2 comma 3. This is how you plot a point. So I plotted a point in first quadrant. Correct. 2 comma 3 lies in the first quadrant. Minus 2 comma 6. Where is minus 2 on x-axis? Over here. Where is just a moment, I should not circle it. Where is 6 on y-axis? Over here. Draw a horizontal line from 6. Draw a vertical line from minus 2. Right? So this is the point where these lines intersect. So this is minus 2 comma 6, which lies in the second quadrant. Absolutely correct. Minus 3 comma minus 4. Where is minus 3 on x-axis? Here. Where is minus 4 on y-axis? Here. So if I draw a perpendicular line, and if I draw one more perpendicular line and find the location of this point, which is minus 3 comma minus 4, both negative, third quadrant, absolutely perfect. Okay, what about 4 comma minus 5? Where is 4 on x-axis? Here. Where is minus 5? Over here. Draw a line. Right, so this is the point. What are the coordinates? 4 comma minus 5 plus minus, which exactly matches with the sign convention of fourth quadrant. So this is how you plot points. This is how you figure out what are the signs and in which quadrant they will lie, even without looking at the points in the Cartesian plane, just by knowing the sign convention. So that's why sign convention according to quadrant number are very important. So you learned what are the numbers of the quadrant. First quadrant is here, the right top, then left top is second quadrant, then left bottom is third quadrant, and right bottom is fourth quadrant. Okay, remember the sign conventions, very very important. So you know now how to plot the point, right? You know what is the sign convention also. Okay, great. So we have done one more topic. Okay, these are about mirror images, which I'm not very much keen on teaching you right now, because first our basics should be very very strong enough. Mirror images can be learned a little later in the chapter, uh, maybe in the difficult problems. So this I'm going to teach you in the class. Okay, let us start with some NCRT questions. How will you describe the position of a lamp on your study table to another person? Now, see, this question should not be solved by you without understanding, or at all. If at all I say that you don't solve this question, it will be okay. Because these are not the types of questions which they are going to ask in exam, right? These are not the questions which they will ask you in exam. How will you describe the position of a table lamp on your study table to another person? See how they have drawn it an example, because if of course your study table might be at some different position. This is just an example, right? So see what they have written. Consider the lamp as a point and table as a plane. So the concept they are explaining with the example of table and point on the table, that is the position of table lamp. Consider any two perpendicular edges of the table. So they have considered any two perpendicular edges of the table. So in this they have considered, let me show you, this edge and this edge. These two edges they have considered. Okay. Measure the distance of the lamp from the shorter edge, 30 centimeter, let's say. Again, measure the distance of the lamp from the longer edge, let's say it is 20 centimeter. So we write the position of lamp as 30, 20 or 20, 30, depending on the order we fix. So very simple, right? So this is how they have solved this. Don't solve this question in your notebook 3.1 first question. You can let it go. This is just for your understanding. These are not the types of questions which are going to be solved by you. Question number 2. Street plan. A city has two main roads which cross each other at the center of the city. These two roads are along north-south direction and east-west direction. All the other streets of the city run parallel to these roads and are 200 meters apart. There are about 5 streets in each direction. Using 1 centimeter is equal to 200 meter, draw a model of the city on your notebook. Represent the roads or streets by single lines. Again, no need to do this. This is a project based kind of question. I'm going to show you the solution and discuss it with you. You don't need to solve it. Okay. There are many cross streets in your model. A particular cross street is made by two streets, one running in the north-south direction, another in east-west direction. Each cross street is referred to in the following manner. If the second street running in the north-south direction and the fifth in the east-west direction meet at some crossing, then we will call this crossing street 2, 5. Using this convention, find how many streets can be referred to as 4, 3 and how many cross streets can be referred to as 3, 4. Okay, now see, this is the answer. You see this, let me show you. Yeah, this is the east-west street running from the middle of the city. This is the north-south street running from the middle of the city. Both are perpendicular to each other. Now there are 5 streets, 1, 2, 3, 4, 5, parallel to east-west street, right? This street, and there are 5 streets, 1, 2, 3, 4, 5, parallel to north-south street. And they all these 5 streets cross these 5 streets. 5 vertical and horizontal streets cross each other. They are not vertical and horizontal, but in map it will look so. See, uh, where is 4, 3? So where does the fourth street cut the third street? See, this is the point. And where is the 3, 4 point? 3, 4, 4 crossing point, where the third street cross the fourth street. So this point. Are they the same streets? Are they the same crossings? No. Yeah, they are not the same crossings because they are ordered in a specific manner. If you change the order, the location will change. And this is an analogy to your graph, to your Cartesian plane, right? So just have a look at this answer. No need to solve this. Okay, so the first exercise you can skip altogether. We can start with the second exercise. Now all the questions in the second exercise are very simple, based on plotting the graphs and answering some questions related to graph. So I'll just uh, guide you through the exercise and then you can solve them, right? If you don't have a graph paper, then you can leave those questions, not a problem. If you have a graph paper, then solve it, because anyways we have to solve it sooner or later. So if you understood the concept now, it is better to solve it right now on the graph paper. But if you don't have graph paper, just understand the concept, keep it with you and keep it in your mind, and as soon as you get your hands on a graph book, you buy it from somebody or borrow it from somebody, uh, uh, you can solve the exercise, right? Write the answers of each of the following questions. What is the name for horizontal and vertical lines drawn to determine the position of any point in the Cartesian plane? Tell me. You should be able to tell me this. The name of horizontal and vertical lines drawn to determine the position of any point in the Cartesian plane is x-axis and y-axis. What is the name of each part of the plane formed by these two lines? Quadrant, right? Each part is known as quadrant. Write the name of the points where these two lines meet. These two lines meet at the point which is known as origin, right? Axis, AXES, plural, x-axis and y-axis are their names. Quadrants with numbers 1, 2, 3, 4 as I showed you, and origin is the point where they meet at a point. Okay, see the figure and write the following. The coordinates of B. Can you tell me the coordinates of B here? What are the coordinates of B here? See, what is the x coordinate of B? -5. What is the y coordinate? 2. So B's coordinate are 5 minus 2. Like that you have to solve the whole question. Okay. Everything, whatever questions you see here, you have to solve. I am not going to solve for you. This is your exercise. There is third exercise also. In which quadrant or on which axis do each of the following points lie? Very interesting. -2, 4. What is the sign convention of -2, 4? -2, 4 has a sign convention of minus plus. I'm sorry. Minus comma plus. And minus comma plus is the sign convention of which quadrant? It is the sign convention of second quadrant. So this point will lie in the second quadrant. What about 3 comma minus 1? Plus minus. It will lie in the fourth quadrant, right? -1 comma 0. This is interesting. So if I look here, where is -1 comma 0? See, -1 comma 0 is over here. In which quadrant does it lie? See, -1 comma 0 does not lie on any quadrant. It lies on x-axis. So the points which lie on the axis, x-axis or y-axis, they are not said to be lying in any quadrant. It lies on the axis. Okay, so there are more such questions. Please solve this. Plot the following points in the table, choosing suitable units for distance on the axis. So there are some points. So they are being given in the form of a table. So the first point which you look here can be written as an ordered pair as -2, 8. The second point as -1, 7. Third point as 0, -1.25. Right? And so on. So you have to plot these points and choose a proper scale and plot the point. Okay. So that's the third question, and then there is an exemplar which I'm not going to discuss right now. So basics should be clear. For that, whatever we have discussed till now, you have to keep in mind, right? And solve the exercises. I have showed you the graph, very important part of the chapter, the graph. which determines your coordinate axis, right? So that was the chapter 3, coordinate geometry. Very simple chapter, new concepts but easy concepts, right? Questions are also easy, exercise are small, so just get over with it. We are going to do one more chapter this week. I'll tell you more about it in the group. Okay, see you in the next class. Bye bye.